Good day, ladies and gentlemen. This podcast is about quadratic equations. This presentation is thanks to our team Keerti, Malladi, which is I, Teodora, Nedelkoska, Kelvin, and Kasfia, Parvez. The word quadratic comes from the word quad, which means square, as its squares are available such as x squared. There is no general formula to calculate geometrical calculations, so Pythagoras and Euclid, famous mathematicians, decided to make a general formula, and that formula is the quadratic equation. A quadratic equation looks something like this. ax squared plus bx plus c is equal to 0, where both a and b are coefficients and c is a constant. The different way of solving the quadratic equations are square rooting it, factoring, applying the quadratic form, completing the square. In this video, we will be exploring the three main ways to solve quadratic equations: factoring, completing the square, and using the quadratic equation. Square root of a number is a value that when multiplied by itself gives the number. The square root method is based on the following properties. If you take the square root on both sides, the variable's value will not be changed. The first step is to isolate the term with the squared variable. Once the squared value is isolated, you take the square root of both sides, which removes the square. The variable is then solved easily. It is possible for the quadratic equation to have two possible answers. For example, the square root of 4 is 2 or negative 2. Likewise, when the square root of 16 is equivalent to 4 or negative 4 again. Factoring the polynomials involves separating the polynomial and simplifying it. Therefore, when the simplified versions are together, they equal to the original polynomial. For example, factor 5x minus 15. The only thing common between the two terms is a 5. So therefore 5 is factored to the front. Therefore 5x minus 15 is equal to 5 brackets. When 5 is divided out of 5x, only an x is remained. As same with 15. When 5 is divided out of a minus 15, a minus 3 is left behind. Therefore, you are left with x minus 3. You put x minus 3 inside the parenthesis, and therefore your answer would look like 5x minus 3 in the brackets. Using the quadratic formula. The quadratic formula uses the a, b, and c from the ax squared plus bx plus c, where a, b, and c are the numerical coefficients of the quadratic equation. For example, if you're given this equation, x squared minus 2x minus 3, then a is equal to 1, b is equal to negative 2, and c is equal to negative 3. The quadratic formula is derived from the process of completing the square. For example, if a is equal to 1, b is equal to negative 2, and c is equal to negative 3, you apply it in the quadratic formula, which is x is equal to minus b plus minus root b squared minus 4ac all over 2a. Applying this in there, you'd get x is equal to 3 or x is equal to negative 1, completing the square in standard form. Solve the equation x squared minus 10x minus 20 is equal to 0. The constant negative 20 needs to be moved to the other side, which gives you x squared minus 10x is equal to 20. To complete the square, to take half of b, then square that number, in this case, the result of b over 2 whole squared. So you take negative 10, which is b, divided by 2, which you get negative 5, and then square it, you get 25. You are left with x squared minus 10x plus 25 is equal to 20. Since you added a 25 on the left hand side, you have to add 25 on the right hand side to make it balance. You are left with x squared minus 10x plus 25 is equal to 45. You complete the left hand side to a square, which is equal to x minus 5 whole squared is equal to 45. Now, you further simplify it, take the square to the other side, you get x minus 5 is equal to root 45. Finally, x is equal to 5 plus minus root 45. Completing square in vertex form. Now, imagine you're given the equation y equals x squared plus 12x minus 32, and you're expected to change that into the vertex form. So, the standard form of this equation is y equals ax squared plus bx plus c. Now, you want to put in the vertex form, which is y equals ax minus h whole squared plus k. Now, the way you'd want to do this is take the constant, which is the negative 32, on the right hand side, and take it to the left hand side by plussing it. So, you get y plus 32 is equal to x squared plus 12x. Now, you're turning the right hand side into a perfect square trinomial by finding the c, the constant, factoring trinomial into binomials. So, x plus 6 bracket x plus 6 is equal to x squared plus 12x plus 36. In this case, you're trying to find the constant. Now, again, as said previously, if you add 36 to this side on the right hand side, you'd have to add 36 on the left hand side. So you take the 36 to the other side and you get y plus 32 plus 36 is equal to x squared plus 12x plus 36, which is equal to y plus 68 is equal to x squared plus 12x plus 36. Factoring perfect square trinomial. Now, since you have x squared plus 12x plus 36, what you'd want to do is make that a square. So y plus 68 is equal to x plus 6 whole squared. Now you got 68. You want the y alone. Now take the 68 to the right hand side. So you're left with y is equal to x plus 6 whole squared minus 68. So the vertex is negative 6 over 68, where the h is the negative 6 and the k is negative 68. Moving on to applications of quadratic functions. Quadratic functions have various applications in everyday life, mostly due to the shape that they form when graphed. This specific shape, known as a parabola, has a vertex, which is either the highest or the lowest point on the graph, i.e. either a maximum or minimum. The line that passes through the vertex and divides the parabola into two mirror images is called the axis of symmetry. The points where the graph passes the x-axis, i.e. the y value is 0, are called x-intercepts, or zeros of the function. While the point where it passes the y-axis, i.e. the x value is 0, is usually called the y-intercept. The least complex quadratic function is a function at y equals x squared, and can be used as a template when plotting the graphs of more complex quadratic functions because it has the vertex at the point 0, 0, and is symmetrical about the axis. Graphs of the quadratic functions are useful in producing mathematical models of a movement of an object. One such movement is projectile motion, which is the movement of an object near the Earth's surface along a curved path, under the action of gravity, of course. This motion has a distinct parabolic shape. Examples of projectile motion include the movement of a ball when thrown in the air at an angle other than 90 degrees, and the motion of a rocket or missile. Quadratic equations helped early scientists in concluding that the orbit of planets around the Sun are not circular, but actually elliptical, which is basically a parabola and aided Galileo's understanding of acceleration. If an object moves in the same direction without a force acting on it, then it continues to move with the same constant velocity v. If the object starts at the point x is equal to 0 and moves for the period of time t, the position of the object is given by x is equal to vt. Because this is a constant force acting on the object, which is gravity and friction. This produces a constant acceleration, which is a. If the starting velocity is u, the velocity v after time t is given by v equals u plus at. Thus, the position of the object f can then be calculated by the formula s is equal to u times t plus half of at squared. Similarly, the stopping distance of a car can be calculated if it moves at a velocity u, with a constant deceleration of a. The stopping distance s is given by the formula s is equal to u squared divided by 2a. The formula shows that by doubling the speed, we have quadrupled the stopping distance. Another use of the quadratic functions is found in ballistics, which investigates the movement of objects under gravity. An example is the previously mentioned projectile motion. Supposing we have an object that moves in the y direction with velocity v and a constant acceleration r, and in the x direction with a constant velocity u. The position at time t can be calculated by the formula y equals v over u times x minus r over 2u squared times x squared. Other uses of the quadratic function in the graph include calculations of speed and area, determining life expectancy and products, design of sounds, and they even lead to the invention of mobile phones. So, now we know more about quadratic equations. Here's a quick recap of this presentation: the methods of solving the quadratic equation, what square roots are, what factoring is, how to use the quadratic formula, completing square, vertex form, applications of the quadratic equation. I hope now you have a better understanding how to use quadratic functions and how to apply them to everyday life. So, this is the end of the podcast. Thank you for listening and tuning in.